rapidly marching toward the end of the year. Here we have the answers for page 353 and 354. Are you ready? Here we go. Number 4 on page 353. By the way, checking my notes, making sure that is where we started. Yes, 4 through 9 all. Number 4 is intended to be really easy because here's the concept. I know the diagram looks kind of messy and ugly, but wait just a moment. Consider the 38-degree angle and the x degree angle and the, I'm running out of colors here, and the, let's keep it yellow, and the y degree angle. Don't they all intersect the same arc? Therefore, aren't all three of those going to be half the measure of the same arc? And if all three are half the measure of the same arc, then all three must be congruent. So x is 38 and y is 38. They're all 38. And we move on to number 4. No, that was 4. Number 5. Number 5, notice please that this segment here is a diameter. Because this is a diameter, we know that the arc measure all the way around here has to be 180. Well, first of all, by the way, x is straightforward. You don't have to know that to get x, because we know that the inscribed angle has to be half of its intercepted arc. The intercepted arc is 50, so the angle must be 25. But if this arc is 50, then this arc has to be, because it's a semicircle, 50 plus what? 50 plus 130 is 180. So if the red arc, what red arc? This red arc. If the red arc is 130, then the inscribed angle, angle y, must be half of 130. So y must be 65. And by the way, we also know, although they didn't ask for it, because we have here an angle that's inscribed in a semicircle, we know its measure has to be 90. Which tells us that these two also have to add up to 90 so that all three can add up to the famous 180. So what's 65 plus 25? 90. It works. Everything fits together perfectly. Number 6. For number 6, this should be very straightforward because we have a corollary that says when you have an inscribed quadrilateral, inscribed meaning all 4 vertices are on the circle. If you have an inscribed quadrilateral, then opposite angles must be, what's that word? Yes, supplementary. So x has to be 70, so they can add up to 180. And if this guy is 85, this guy must be 95, so that those also add up to 180. Because opposite angles of an inscribed quadrilateral will be supplementary. We proved that in the previous video. Number 7. Let's see. We know this guy is 60. Let's highlight the 60-degree angle. We have an inscribed angle. And remember the definition of inscribed, which is going to become even more important in the next and last section. An inscribed angle has its vertex on the circle. Not inside, not outside, but on the circle. So if I have an inscribed angle here, then its intercepted arc will be twice the angle, or the angle is half the intercepted arc. So if the angle is 60, then x must be 120. But wait just a moment. Here we go. I keep missing. Here we have a chord and a tangent. We have a theorem that tells us that when we have a chord and a tangent, the angle will also be half of its intercepted arc. So if x is 120, then y must be 60. So x is 120, y is 60, because it must be half of 120. Number 8. For number 8, what do we have going on here? Best approach for this one. Well, we know that we have here an inscribed angle whose measure is 40. What does that do for the intercepted arc? If the angle is 40, the intercepted arc must be 80, because the angle is half the arc. So this arc is 80. And yes, I know they did not ask for that. But wait a moment. Here we have a chord and a tangent. This angle has to be half of its intercepted arc. So y, which I've obliterated there, y must be half of 80. So y is 40. All right, what else can we do here? Finding x. There are two ways to get x. One way to get x would be to say, hey, wait a minute, I know that the entire circle has to be obviously 360. And of that 360, we already have 80 and 150 of it taken up. That's going to be 230. What's that leave us for the remaining arc up here? It must be 130. So this arc is 130. If that arc is 130, then now we look at this angle and its intercepted arc. Ah, yes. If the arc is 130, then the angle must be 65. And yes, there's another way to go about that. Let's see, what was that other way? We know that what? My diagram is so messed up now, I'm not seeing the other way that I had in mind. We got that as 40, we know this is 65. Oh, we already knew that. 40. Oh, this angle. If this arc is 150, then this angle formed by a tangent and a chord must be 75. If that's 75 and this is 40, that adds up to 115. So what's that leave for this guy? That would leave, again, 65. Yes, it all comes down to knowing these corollaries and theorems. And I've mentioned to you before, the way I write my tests, I don't like to incorporate a whole bunch of concepts into one diagram. On the test, it'll be one concept per diagram. Okay. Number 9. Well, let's say, oh, isosceles triangle, that's going to be important. That means that whatever x is, y must be the same thing. That makes it easy. If the arc is 80, then its inscribed angle must be half of 80. So that angle up there at the top must be 40, because the angle is half its intercepted arc. Well, if that's 40, we know the angles of the triangle have to add up to 180. So if that's 40, what's left? We have another 140 to account for. And of that 140, it's got to be split equally between these two because it's an isosceles triangle. Therefore, x and y must both be 70. And we're done. We move on to the next page. 354, number 2. More of the same kind of stuff. This is more like a typical test question. If the angle here is 65, We know that is going to be half of its intercepted arc. Well, if 65 is half of the arc, then the arc must be 130. So that the angle is half the intercepted arc. Well, likewise, looking at that 60-degree angle and its intercepted arc, if the angle is 60, the intercepted arc has to be 120. And we're done. Oh, and to find z, details, again, there are two ways to find z. One way is to say, well, I know the whole circle is 360. Of that 360, I've already used up 130 plus 120. I've used up 250 of it. Therefore, what's left for the remaining arc? 110. Z is 110. Now, they didn't ask for it, but if z is 110, what's that do to this angle? Well, it's got to be half of the intercepted arc. So this angle must be 55. Now, to check ourselves, what should these three angles add up to? 180. And guess what 60 plus 65 plus 55 is? 180. It works. We move on now to number 4. Going by evens now. For number 4, what's going on? Again, they're not making this very challenging. It seems like the classroom exercises on the previous page were harder than these. Here I have an inscribed angle of 55 degrees. Its intercepted arc must be twice that, because the angle is half the intercepted arc. So y must be 110. Ta-da! Well, again, in green, we have another inscribed angle with its intercepted arc. We know the angle is half the intercepted arc, so it must be 70. So x is 70. And then we could just add these up, because we know they have to add up to 180 to figure out the remaining angle, which would give us the remaining arc. Or, might be a little bit simpler, to just remember, oh yeah, the whole circle is 360. So far I've accounted for 110 and 140. So far I've accounted for 250. So what's left for z? 360 minus 250. I've got 110 left. So z is 110. Oh, interesting to note that if this is 110, and this is 110, that makes this an isosceles triangle, where that's 55, this is also 55, and we just happen to have ourselves an isosceles triangle. Not that we really care in this particular problem, but it's just an interesting observation. Number 6. Oh, look at this. We have a diameter. If that's a diameter, then that means that that's a semicircle, and of course, that's a semicircle. Any angle inscribed in a semicircle will always be 90 degrees. Any angle inscribed in a semicircle will always be 90 degrees. Any angle inscribed in a semicircle will always be 90 degrees. X, Y, and Z are all 90. Last problem, number 8. The key here, now I hope you noticed it, the key is that these 3 segments are all congruent. Remember that congruent chords have congruent arcs. So if this arc is 80, then this arc must be 80, and x, this arc must be 80. Because congruent chords have congruent arcs. 80, 80, bingo, 80. So what about y? Well, if we now know, and this the key here is you couldn't get y until you know what x is. Because we know this is 80. Haha, there it is, inscribed angle. The inscribed angle has to be half its intercepted arc, 80, y must be 40. Ta-da! Now what about z? Well, for z, we need to make use of the fact that all three of these arcs are 80. That's 240 used up so far. 240 being used up from here around to here. Well, what's that leave for my remaining arc? 240 subtracted from a total of 360 leaves me with 120. So if this arc is 120, then tangent, chord, this angle must be 60. Z is 60. So x was 80, y was 40, and z was 60. Okay, we're done. In the next video, we'll be seeing the last section we're going to do for this year, and then we'll start thinking toward the test. Yes, there will be a test. Last day of school, the 21st of March. No, it starts with M, the 21st of May, next Thursday. Yes, I know we're supposed to have tests on Fridays, but as I've already mentioned in a post on Google Classroom, that because there is no school on Friday, I've been given permission to give you the test on Thursday, provided there were no conflicts with other classes, and there are none. So the test will be at 1 o'clock on Thursday. All right, that's it. See you then.